Okay, welcome to week 3, our full week of online learning. Just a couple things before we start with the lesson for the week. So a couple things. If I put a 0 redo on the grade, make sure that you're looking at comments, that you're fixing things, ask me questions. Make sure you're watching the video before you actually try the assignment, because I go over specific things of what you need to do. If you need more help, just reach out to me. You guys have been good with communicating, so keep that up. So what we're going to look at today, it's going to have this one video for all week. I have 6 main examples, and then I have 3 extra if you need more to look at later. So we're going to look at simplifying radicals. So this up top is just a kind of what we've already done, just to kind of review. And then my bottom 3 are what we're going to be looking at today. And then I have a couple more for us to look at. Let's look at what we did last week about rational radical form. So remember, the 2 was the top. Our exponent is made up of actually a power divided by the root. So this meant the cube root of 8 squared. So what is the cube root of 8? So we can break it down as 4 and 2. We got 2 and 2. So we have 3 of the same thing. We have 3 2's underneath. So the cube root of 8 is 2, and 2 squared is 4. So that's what we looked at last week. So when we're looking at this, what does this mean? It means x, the power is 3 and the root is 3. So 3 over 3 is just x. So when we're simplifying radicals, so I'm going to give you a shortcut for the variables. So what this means is we have 7 x's underneath. So I'm just going to write out x times itself 7 times. 4, 6, 7. So if it's under the radical, it's the 4th root. So you need 4 of the same to take it out as 1. So I could circle 4. I have a group of 4. I can take out 1x, and then underneath the 4th root, there are 3 x's left. So that's what we're going to use for the bottom examples in a minute. But here, we know the exponent is made up of a power divided by the root from what we looked at last week. So 4 can go into 7. So I can write it out like this, but I don't necessarily need to. 4 can go into 7 one whole time, and we have a remainder of 3 left. So 4 can go into 7 one whole time, and then we have a remainder of 3 underneath the 4th root. That is how we're going to simplify radicals today. So if you can write down example 1, I have the cube root of 80 x to the 5th y to the 8th. So I will always break down a number like I did here. So let's break down 80. 8 and 10. 8 is 4 and 2. 2 and 2. We got 2 and 5. So remember, so you've got to look at the root. What number is the root to know how many of the same to take it out as 1. So cube root. So it means you need 3 of the same. Even though there's 4 2's, only 3 of them are used to take out. So that would be 8, like what we did over the cube root of 8's too. So we can take out, so I'm going to start with taking out a 2. And I'm going to leave some space. And then make sure you put in the handle, the root is a 3 here. So I have 2 times 5 left, which is 10. So make sure when you have stuff that's left, you multiply and keep it under the root. So let's use our shortcut here. It's power divided by root. So the root goes into the power how many whole times? 3 goes into 5, 1 whole time. I can take out 1x, because you can think of there's 5 x's there. I need 3 of them to take it out as 1. And then I would have 2 left over. So x squared, so I had 5, 3 of them take it as 1x, and then 2's left underneath the cube root. 3 can go into 8 2 times, so I'd have y squared. So 3 goes into 8 2 whole times, and again I would have 2 that's left. So I would say it's 2x y squared times the cube root of 10x squared y squared is how we're going to simplify the radicals. So let's look at another example. Just put a little space. 2. I got the 4th root of 32 x to the 5th y to the 11th. So 4th root of 32 x to the 5th, y to the 11th. So let's break down 30. So numbers, I want you to break them down. So we've got 4 times 8, 2 and 2, 2 and 4, and then 2 and 2. So 32 is made up of 5 2's. How many do we need to take it out as 1? Well, what's the root? It's the 4th root. So I need 4 to take it out as 1. So I'm going to circle a group of 4. So that means I can take out 1, 2 out. I'm going to leave space for my x's and y's. And then underneath the 4th root, I have a 2 that's left. So I need 4 to take it out as 1, and then I have 1, 2 left. So 4 can go into 5. How many whole times? 1 whole time. And then we have 1 remainder, just like our 5 2's. There's 5 x's. I need 4 to take it out as 1. I have 1 left. 4 can go into 11 2 times, because 4 times 2 is 8. Then I can think of 11 minus 8. There would be 3 left. So y cube's underneath. So 4 can go into 11 2 whole times. The power, the root goes into the power. 2 whole times, 3's left. So that would be this answer for number 2. 2xy squared times the 4th root of 2xy cubed. Okay, so let's look at 3. So for 3, write down, it's the cube root of 54 plus 2 cube root of 2. So it's cube root of 54. Remember, there's really just a 1 in front here, plus 2 cube root of 2. So when we're talking about like terms, they had to have the same number underneath the radical. They had to have the same index and the same radicand, which is the number underneath. Okay, these do not have the same number as is, so we can't just put them together unless they're alike. So we can break down 54 though. So it's 27 and 2, 9 and 3, 3 and 3. So we need a group of 3 to take it out as 1 unit. So I have 3 3's. So I could say this is 3 cube root of 2 plus 2 cube root of 2. Now, do they have the same number underneath? They're both 2's. Do they have the same index still? Yes, their roots are 3's. So then you could just add the like term, which is 5 cube root of 2. So we say it's 5 cube root of 2. So I have one more of this example, and then we have some multiplication to look at. So if you could just pause it for a minute, and then I'll erase this. Okay, so for number 4, I have another one. I wrote them down so I could check it out with you. So it's 3 square root of 40 minus the square root of 90. Okay, so think about, we've already looked at this type. If it doesn't have an index, remember it's 2. It's the square root. It's a number times itself. So let's break it down. 4 and 10, 2 and 2, 2 and 5. So if it doesn't have an index, remember it's a square root. You're looking for a pair of the same numbers, which we have a pair of 2's. So remember, when we brought that 2 out, we're multiplying it by the 3 that's already out front. So we'd say that this is 6 square root of 10. 90 is 9 and 10. We got a pair of 3's, and if you don't necessarily have to break it down if you already know your square root, but I'll just write it down. So we have a pair of 3's. There's really a 1 out front. It's really negative 1. So it's negative 3 square root of 10. So our index is the square root, and then the radicand is a 10. So now they're like terms, so we could say 6 minus 3 is 3, keep the root 10. So it's 3 root 10. All right, let's try for number 5. I have a multiplication one. So I have, for 5, I have 5th root of 3 n to the 6th times by the 5th root of 2 n to the 7th. Okay, so if to combine, add and subtract, they have to be alike. We can multiply as long as it's the same index, and they're both the 5th root. So for multiplication, push it together, because you don't want to have to simplify this one, and then multiply and then simplify again. So I would multiply first. This is 5th root of 2 times 3. Remember, when we multiply, what do we really do with exponents? We have 7 ends and 6 ends. That gives us 13. So when we multiply, our property of exponents says to add the exponents. Okay, so 6 is made up of a 2 and a 3. Okay, is that going to be 5 of the same thing underneath it? So if you can't simplify, 6 is going to stay underneath the radical. So just your ends. 5 can go into 13 2 times. So we'd say n squared. The 6 is underneath the radical. And what would be the remainder? So you can think of it like this. 5 goes into 13 2 times. That's why we have n squared. That'd be 10. So there'd be 3 left over. So we could say n cubed is underneath. So n squared times, what am I forgetting? What root is it? It's the 5th root. So don't forget, this is where I'm going to see answers wrong. Just make sure you remember the index is the 5 there. So let's try one more of that type. Put it right here. So for number 6, my examples fell. Oh, no, they're right here. All right, number 6, we've got the 3 times the cube root of 4x squared times 2 cube root of 4x to the 5th. Okay, just like when we multiplied radicals, numbers outside get multiplied. We got 6 here. As long as it's the same root, we can multiply underneath. 4 times 4 is 16. And then we multiply, we add exponents. We get x to the 7th. So I would break down 16 is 4, 4, 2 and 2. We got 4 2's underneath. And so it's cube root, so you need 3 of the same to take it out as 1. So circle the cube root. So you're really taking out 1, 2, and you multiply by 6 that's already out front. So we've got a 12. 12. And then 3 can go into 7 twice. So we've got x squared. And then underneath the cube root, there should be 1, 2 left. And there should be 1x. Because 3 goes into 7 2 whole times with 1 remainder. So it should be 12x squared times the cube root of 2x. Okay, so if you feel like you're good with this material, go try the simplify radicals. For the first one, I have the answer key that's attached. It's in the instructions. You should be able to see it. So I need work shown. So if I just get answers, that's when you're going to get a 0 on the assignment, and I'll say to redo it. So showing work would be breaking it down, showing me you're multiplying it together first. So again, if I just see answers, I'm going to say redo the work. So because I've given you the answer key. So if I give an answer key, I'm not going to check the answers. You're responsible for it. I'm going to try to check one assignment a week for a correctness. But again, if I just get the work or if I just get the answers, I'm going to ask you to redo. But I do. So right now, if you feel like you need a couple extra questions, I have 3 more examples, one of each type, to try right now with you. So again, if you're good, go do. You have 2 assignments for the week plus 1 on Delta Math. All right, so if you're good, have a good week. If not, come back and check out anytime. I got 3 more examples. So let's do 1 more of each type. Okay, so I got this one is my extra examples. Let's try this one is number 7. I've got the cube root of 81, x to the 5th, y to the 7th. Okay, so cube root of 81, x to the 5th, y to the 7th. Okay, so I want you to break down the numbers to its prime factorization. Okay, so we've got 4 3's, and we need 3 of them to take it as 1. So I'm going to circle a group of 3. So we'd say this is 3. Well, how many x's can come out? Well, 1 x can come out. How many y's can come out? 3 can go into 7 2 times. Then underneath the cube root, you have 1 3 left. Okay, 3 can went into 5 1 whole time, and you have a remainder of 2. So x squared. 3 can go into 7 twice, and you have a remainder of 1. which you don't need to put y to the first, it's just y. So then you would say it's 3xy squared times the cube root of 3x squared y. Okay, so for 8, I have one on adding. It's 3 cube root of 80 minus 2 cube root of 10. Okay, so 10, you're not gonna, this is a 2 and a 5. So our goal is to see if we can get this to say 10. So let's start here. 8 and 10, 2 and 4, 2 and 2, 2 and 5, which I need 3 of the same. So look at here, I have 3 2's. So I'm bringing, cube root of 8 is 2, so I'm bringing 1 2 out. I multiply by the 3 that's there. So I say this is 6 cube root of 10, because 2 times 5, minus 2 cube root of 10. So now I can combine them because they're alike. 6 minus 2 is 4. So I'd say it's 4 cube root of 10. Make sure that the index is smaller than the number out front. So I have 4 cube root of 10. It's a box. Okay, let's try one more on multiplication together. We've got 2 times the 4th root of 9, x to the 7th, times the 4th root of, I had 9x to the 8th. 9x to the 8th. Okay, so 2 is getting multiplied really just by the 1 in front there. So I got 2. 4th root of 9 times 9 is 81. And then x to the 15th. Okay, so 81 had that is 9 and 9, 3 and 3, 3 and 3. Has 4 3. So it is, we'd say it's a perfect fourth. So we can bring a 3 out times a 2. Should be 6. So 4 can go into 15 3 whole times. So x cubed. And then underneath the 4th root, make sure you put a little 4 in the handle. 4 goes into 15, so you'd be 4 times 3 is 12. So 15 minus 12 should be 3 left over. So x cubed. So we'd say that is 6x cubed times the 4th root of x cubed. All right, so go try the rest of them. Let me know if I can help in any way. All right, have a good week, everyone.